As one of the primary tasks in virtual reality systems, object manipulation is used in many different application domains such as 3D modeling, game development, and immersive data exploration. However, its primary input modality, which uses virtual hands to directly manipulate an object, has long been criticized for being inefficient and imprecise, and likely to induce arm fatigue in longer interaction scenarios. In this research, we investigated different integration, coordination, and transition strategies when incorporating gaze into current system with mid-air input for 3D object manipulation in VR. We examined the design space that consider how gaze and hand input are integrated into different phases in the manipulation task, how they coordinate with each other when starting the manipulation, and how to transition from one to the other during manipulation. Based on the design space, we developed 4 gaze-supported manipulation techniques. With gaze grab, the gaze-indicated target snaps to the hand position once the selection is confirmed. Next, the hand takes full control of the selected targets during the manipulation phase until the trigger is released. To manipulate an object through remote hand, the user first points at it with eye gaze, then confirms the selection with the hand trigger. The target then follows the rotation and translation of the hand without snapping to the hand location. 3D Magic Gaze establishes a safe region around the target once the initial eye-based selection is confirmed. If the gaze point is within the safe region, only the hand can control the transformation of the object. Otherwise, when the gaze point is outside of the safe region and if the hand movement exceeds the threshold, the object snaps to the gaze point direction. Implicit gaze also forms a safe region around the target once the eye-based selection is confirmed. If the gaze point is inside the safe region, hand input will control the object's transformation. Otherwise, if the gaze point is outside of safe region, the object snaps to gaze point direction. We also introduced a mechanism which resets the safe region automatically based on user's gaze behavior to prevent the gaze cursor from being overactive. We evaluate the techniques through 2 user studies. In the first study, we focused on the primary working space where all objects located in front of the user and were within arm reach distance. We assessed the techniques in terms of user performance and experience. In the second study, we further evaluated our techniques in a larger virtual environment with distant objects and embedded the design techniques into realistic workflows. Our findings show that gaze might not offer significant performance benefits for transforming objects in the primary working space, but can be useful in a larger environment with distant objects. Gaze input was also shown to mitigate the arm fatigue issue, and different integration, coordination, and transition strategies can provide benefits for building more usable and efficient object manipulation techniques in VR. Please refer to our paper for more details. Thank you.